Right. I guess I'm actually doing this. Um, I should have done more preparation. Basically, you know what? We're gonna. If I open this, will it capture? Yeah, it will. Um, so this is. I upgraded the computer. Let's not use that one. Let's look at one. Um, this is my upgraded version of the computer. Um, with two ROMs offset. This one's offset by one, so it can, and this goes up by two, so it can read 16-bit instructions because they have the same ROM in them. And this mess is a memory manager. Um, yeah, basically the way it works is the first every tick. This has the first byte, and this has the second byte. I look at the instructions. Well, okay, we have so the zero, which is why this is what this is reading, right? See, this is reading a 32, which is what copy instruction. So the red is immediate, and then basically it has 7 registers, an input and output, 256 bytes of RAM. Yeah, and it can read 2 values at once. Sort of. It can, but the RAM gets a little bit confusing. Um, Basically, the basic way it works is, so for like the immediate, which is just write a value to memory, if this is off, then basically, so that's the first byte. The second byte holds is an 8-bit number that is the value to be written. And basically, the way it works is these last 2 bits control the register. Um, so 0 is register 0 up to 6, which is register 6, and then 7 is input/output. So this would immediately copy the whatever the value is to the output. If you set this, it's a pointer. This wouldn't work, but this would be, what is that, 3? This would mean look at the value in register 3, interpret the value as an index into RAM, and write the immediate value to that RAM address. That's basically it for that. Copy is the same thing, destination, except the upper nibble of the second byte also works the same way. It will be the first bit, or it will be second, third, and fourth bits are, well, wait, I don't know which way you're supposed to count them from. Indicate a register, and then this, if this is set, well, obviously it'd be in the next byte. It means that you're going to, so this destination, then the source is in the next, is the upper half of the second byte, and the first bit, the most significant bit, just tells it whether or not it's going to read. If it's set, then instead of reading from the register you've specified, it'll read that register value and then read whatever's at that RAM address. If you try and read from RAM and write to RAM at the same time, that's undefined behavior. If you're writing, if it's the same address, it might work. It probably works. If you try and read from, you'd be passing 2 different addresses in on the address line of the RAM. You probably get an error of some kind. What else we got? Maths. Oh yeah, the maths. The second byte is just upper nibble is a register with the first bit telling it to be a pointer if it's set. Lower nibble is a second register, so it's this combined with that. And then a destination register. So you can pick any two registers, combine the values, and then put them somewhere else. You cannot, if you're doing maths, you cannot write to RAM because I don't have enough bits. You'd have to write it directly to register. And I've only done add and subtract. These would probably be like, I guess, multiply and divide or something. I don't know if my mouse is having some slight issues. Yeah. Let me see it. I'm getting occasional double clicks. Bit operation. I actually forgot to implement this last night, so I had to implement it just now. Is the same thing as the maths, except it does bitwise manipulation. And then this is a test condition, which I think... Oh yeah, this will... You read the second byte. So this is a condition, and then obviously you've got your various conditions. The second byte contains two addresses, one for a value to test, and the second one is an address that gives you a value back. And if the condition tests true, the program will jump to that address. You do have to index this properly. So if you jumped to index 1, you would be jumping offset and be reading garbage, I guess. And that's... double click. That's all I've implemented. The way it works, essentially, this pink line is the write line to memory. The orange one is the first read value, and the grey one is the second read value. So you can see, yeah, like this. Yeah, it decodes instruction bits. If we're in immediate, it just directly... Oh yeah, this lower line is the second byte, and the upper line is the upper byte. It just directly writes the lower byte to the... Basically, if we're writing... Well, I have to get them in a minute. The address, the destination address is always contained in the lower nibble of the first byte. So this just reads that to find out its address. And if we're reading, the value 1, the first value to be read is always contained in the upper nibble of the second byte. And the second value to be read is the lower nibble of the second byte, which is what this is doing. Yeah, so if we're in immediate mode, it just turns on this, which just directly writes the second byte into the right line, and then the address will be... This will just work out what address it's supposed to be saving it to. This second one is what? A copy? Yeah, a copy, which just turns on this, which just reads the first read line and writes it to the right line. It just copies the read to the right. Third one is maths. Yeah, I built my maths component. I've changed it a bit. This is reading the operation, and it is reading it off these two pins. So it's reading the operation off these two pins because those are the pins that are supposed to hold the operation. And then, again, it reads input 1, input 2, and writes. And this does this every time, but the write only gets enabled if we're in the correct mode. This mode for the condition, which again, it's reading the condition from the correct bits off the first byte, performing its checking the condition against the read value, and then if the condition is true and we're in the condition mode, we set the pin to update the program counter and also write the second read value to the program counter. And then bit manipulation mode is, it's a similar thing, right? It takes two values, the input byte to determine its operation, again, from those two bits. And then we only turn on the write if we're supposed to be writing. And then this address nonsense is a bit of a mess. Basically, the read line, I had to update the register component so that it now has, if you turn on, it has one value. If you turn on load 1, it outputs its value in output 1. If you turn on load 2, it'll output its value in output 2. The simplest one is this upper nibble on the second byte, which is essentially the address, because we have two read lines. We have load 1 and load 2. This is the address for load 1. So all this is doing is decoding. Well, if this is on, well, basically this is working out which register and enabling load 1 on that register. That's all. That's what these kind of light green lines are doing. They enable load 1 on the appropriate register, or on the input, which is slightly more complicated because I only have one input and it only has one load line, and then it says write it, turn on the input, and then read it in load 1, which is this kind of purpley line. So load 1 is this purpley line, which outputs up here into this, and then outputs onto the orange. If, however, this bit is set, that means we are reading from RAM. So I should check this color. So this line goes on. So this blue line is the RAM output value. That does not need to be. So basically, what happens is if this line is high, we switch this output to output the RAM output. This OR gate, so we also turn on set the load pin on the RAM so that the RAM reads, and also what is it? This one? Is this one? Which also sets this, which means that the value we're reading on the load 1 line gets sent through here onto the address bus of the RAM. So what happens is we set the address of the RAM for the value in the register, and everything gets turned on, and we load and we output that instead. For load 2, it's similar. It switches this, enables load. What's this for? Oh yeah, that's for that. Yeah. And enables and sets the address to come out and uses the address into RAM. If you're saving, normally, again, it just turns on a save address. It turns on the save pin of the appropriate register. It gets a bit complicated because if you're saving into RAM, it has to read the value. Basically, you can only access you can access 3 registers at a time. But you can only read from 2 at a time. But saving to RAM requires reading from a register. So if you're saving to, which is why you can't do maths direct, which is another reason why you can't do maths directly into RAM. But if you were copying from a register to RAM, your copy would be read on load 1, but your RAM, basically you'd be saving to an address, but we should interpret that address and instead have to load from that register, which is what all this nonsense is. So basically, if this pin is set, which is that we are writing to RAM, but we also need neither of these 2 bits to be set, which are the upper 2 bits in the first byte, basically because this is maths, which can't write to RAM. Bit operations are not allowed to write to RAM, and conditions aren't writing to RAM anyway. So basically what this does is it disables writing to RAM. Well, if the top bit is set, we're in a condition mode. Anything else is writing. So if this bit is set, it's a condition instruction. So writing to RAM gets disabled. By this line, we just disable the decoder. So all of these are off, which means that we don't turn on the save pins. But I mean, it only matters for half of these. Which ones? These ones. These ones are the this one saving. This uses these 7. So if you're saving to output, it just writes directly, essentially, kind of. Yeah, no, it does. We use these to index and enable saving on the appropriate register. If this is set, we don't do any. We don't write at all. And if this bit is if this bit is set or this bit is set, which indicates we may be allowed to save, but we're not allowed to save to RAM, we disable this line. This line indicates that we wish to save to RAM. So it turns on RAM saving and turns on both of these switches. Okay, one of them's a data line. Okay, this was a data line. Yes, because we've got a... It's fine. This doesn't really need to be here, this thing. We've got a save line on here, we've got a write line. So if we're saving to RAM, right, this line goes high, which turns on saving, enables this set of buses, and disables this set of buses, hence the NOT gate, which basically means that instead of enabling the save pin on the register we're trying to... of the register that we've addressed, we instead turn on the load to pin, which means its value will come out on the second load line. We also disable the second load bus. Technically this line could be high as well, I suppose, but we don't care about this because we're not reading from... It may also turn on the load bus to RAM. So basically there could be garbage data in this bus, but we don't care because the instruction isn't allowed to be interested in it, because we're not allowed, because saving to RAM while also trying to read from RAM is undefined behavior. You'd have to be the same address anyway, I think. But yeah, these turn on. I have to have OR gates. We disable these, so we load from one register. The address is therefore on this kind of dark blue purple line. We turn on this, which puts the a low value we've loaded into the address bus. We turn on loading. We turn on saving, and and we save to RAM. So yeah, this is this level. No. This program is written in bytecode. This is an immediate to store the input value in register 0. Oh, no, it's a copy. Sorry, to put it in register 0. We add it to itself, put it in register 1, so that's twice the radius, because basically pi is approximated to 3, so I just need to multiply value by 6. We double register 1, put it in register 2, so it's 4R, then we add register 2 to register 1. And we store the value in output. So this input is 1. So we get 1 and we store it in register 1. We double that and put it in there. Double that and put it in there. And then we will add those two together and output 6. And this works. However, it sucks to write. As you see, I had to write this in binary because even hex is just too confusing, and I can't use the assembly language because I have to make bytes. So instead, I can't move this to a separate monitor very effectively. You know what I'm going to do? Let's take a screenshot. That would really help. Can I just Alt-Tab? What? Just gonna close the Steam window. That way I can't accidentally display my Steam window. So yeah, I'm going to write an assembler because I'm insane. And I'm writing in C++ because I want to write in C++. My brother thinks I'm insane for writing an assembler for this. But I'm doing it anyway. I guess to prove him right. So now I have to remember how the hell to write in C++ because I have not done this for a while. And yeah. And I'll tab back in to see my instructions. Right, so how does this work? I will need to include fstream, and I will be using what the hell am I using? What's it called? Ifstream and offstream. Or will I just use the standard fstream? Basically, yeah, I'm going to write assembler. Do I have to semicolon that? Yeah. Right. I don't have nice formatters like I would in VS Code. Oh, you know what else I'm almost certainly going to need? That. And that. Where does it run? Does it run here? I forgot. I cannot program without the documentation. Stream. Is it? Wait, is it? How do I open the... So you do open... What about if I do an off stream, which is... This is for writing. We do offstream dot open. I should probably use arrays. Hang on. I have somewhere... Is it the mod maker? That's the actual mod maker. Modmaker.cpp. Where is the... Microsoft Visual Studio. Is in GitHub. What's this doing? Oh, it's mucking around with mod folders. Input. IO stream. No. Animation. It's got F stream. Write to file. Right, so how do I make a file? Okay, this isn't going to build because I use Visual Studio 2022 and I've got 2026 now. I'm just going to make the folder. Wait, this is I'm on Windows. Windows has a case insensitive file system that might actually become relevant. It's possible. It's tripped me up before. So how does it make files? Because this isn't making files, it's just calling make directory. So let's say you're making a weapon. There's an advanced weapon tool, is there? No simple weapon tool. I guess I never made one. That's from weapons.h, I would assume, so it'll be in weapons.cpp. Oh, it's giving me a little speedy. This is off-stream blueprints. Oh, yeah, no. But this file hypothetically might not exist. So open. What happens if the file... It doesn't exist? I don't know how to do command line arguments, so we'll just... I can rename things later. Right, so what this realistically need... I know where it'll be running. So I would do like... Stream... Let's call it out file. Then we would have to out dot open string. And then we will call it assembled dot... What are they called? Like assembly or something? What's this level called? Calibrating laser cannons. New program dot assembly. Open with notepad. It's completely empty. That's because this is in circumference. Yeah, okay, so that's file. I found the file. Right. So this... Then I would need to work out how to write... So... Does that work? No, it does. Right, moment of truth. F5. X duplicate 0. Did not do anything. So how does this... What's this? Oh, that's a parameter for the open. My bad. So why is this not working? I'm with the debugger. Oh, where's my stack frame? This is stack. Full stack. We've got an out file. Unable to read memory. Step over. It's attempted to open one. Where's the fail bit? File buffer. Can I run code? Okay, it didn't open. That's a virtual function pointer. iOS base. IO state. Who is my state? Well, I've tested it and I know it didn't open. My state is 2. So I think it failed. The question is why? I don't need to use write. Does it have iOS? Yeah, I do. That should just be in scope. Not in scope, but... Not a namespace. Oh, I know where it is. Oh no. Input.h? It might be an IO stream. No, this doesn't exist in scope. Wait. Okay. Okay, it didn't open. What if I created new text document? No, I didn't open it. No, it wrote nothing. I don't understand why this is not working. The program not running as... Wait, hang on. That might fix it. Yay! Where's the continue? There. Yeah, it worked. It wrote the file. Okay. I actually want to truncate it. And I don't want to do that. I want, realistically, we actually want to go... like that. Yeah, no, and it wrote. Right, there we go. That's that. Done. So I don't need this. It needs a file. It doesn't need a file extension. So the goal here is I'm going to... I guess I'm not allowed to do that. Oh, there you go. This, I'm just holding the mouse down. I'm holding the button down. I do, in fact... need to buy a new mouse. So this is going to be something... I think this is... yeah, that's this file. So... like, immediate... These are going to be... I should probably put in a proper number interpreter in here. So I can take decimal. I know, but I'm not actually doing an immediate. Actually, you know what? I'm going to do all my instructions, my entire instruction set. But the question is, I can still scroll it. So the condition is the first 3 bits. And then... I guess we just put the... you know, I want them in order. Triple red is an immediate, so the immediate then takes as a dud bit. And then takes... I mean, it's going to be a lot of lookup tables, this. It's going to be massive if-else, if-else-ifs nested. And then this should take a second byte, which is a number. So let's say 31, but it does need to be output in binary. And we're going to end with a semicolon. Maybe. Why am I doing this? I'm insane. And then we've got copy. Say it like that. So this is copy destination. I need to support comments. Use hashes. So it's destination then source. My brother would laugh at me. The fact that we was discussing this the other day. How in Shenzhen you put the source and then the destination, like move this from here to there, move from here to there, and he was like, "Oh, in assembly you always put it the other way around," and now here I am, and I was like, "It makes more sense to me to put it the other way around," but here I am putting it this way around. Why have I got a terminal open? Who knows? Then we'll have maths, add, the input and the output are just register 7. So like 2. Right? So we're putting it into register 2 because you can't do it into a pointer. 3 is bit. And then this has let's say 1, whatever. I'm not going to do the ands and stuff. You need it. And then 4 is condition. And then I guess we need like and then we need the first and then the second byte contains what was it? Oh yeah, like right, so that's kind of the basic concept. And then I have stream in file. Those inputs. These has. I'm gonna need some of these. No, Windows. Oh, okay. I desperately need to buy a new mouse. because I just tried to drag the window and I lost control. I lost it because my mouse click got dropped. I can't be, I'm not skipping this. Right, it's the wrong ignore line. Why have I got get paragraph as a namespace of some kind? Oh, this doesn't read files. I need to open. Oh, that's the wrong adventure game. This game. Input this inputs.cpp. It's only. Wait, that should. What's wrong with this? Yeah, function defined. Don't need that one. That one's only on cin, ignore line. Oh, that's some overloads. What's end? Wait, this is a car. Get tag num from file. I should probably do. It's only going to have to interpret. These are only numbers that are actual numbers. So they probably work. I don't know if I'm going to have to write a script for converting. Oh no, this is numbers only relevant for the immediate functions. The only one that can write direct numbers. And I can write them in decimal, which I'm going to do for now. I don't need to be able to read. I don't need floats. Comments. Float from string, user choice, user choice, remove escapes, no escape characters. Yeah, that's fine. Right, now I need to actually write these files, write these functions. Should this be a void? Is that a thing? Yeah, I think you are supposed to do that. Really? Right, so clear space. This is essentially going to go... We're just going to copy the other one. While... I could use numbers here. We just... That's it. Wait, yeah. I think I technically don't need a space there. It's going to auto-insert one. Probably. Yeah. I would not be happy about not having one there. What's this saying? Local variable is not initialized. It's fine. Is this to... Yeah, well... This is while we're not at the end of the file. Then... That's the idea. I can't remember if you initialize these. But I want to... So I guess what we really want to do is while... We're not at the end of the file. Wait, hang on. Do I make a string? Oh, I want to make a... Wait, these don't need... They can just be... They can just be like that. So what this is going to have to do is... You know what? Wait, you know what? Wait, I need to change this. How do I change... Formatting... Unicode. Can I change it? Define with Bing. No, how do I... Page setup? I want... I don't know if this will read properly. Is the problem. Because this is using carriage return line feeds. And this is... Oh no. Use line feeds. Because Windows is happy with line feeds. Everything's happy with line feeds. Linux is not happy with carriage returns. We only need a line feed, which is this. That's a line feed, I believe. It's probably like a CR or something. I don't even know what's this function going to do. I need to use, because I'm like... I considered doing this in JavaScript, and it might have been a better idea. They're split. Empty tells you whether it's empty. Oh, we need a because you would need a vector, wouldn't you? That's the slight problem with this. I'm so used to JavaScript. Well, the reason you can't split a string in C++ is because that would give you an array of strings of unknown length, which would therefore not be an array, and it would have to be a vector, which would be a cross between two standard library extensions or whatever. Okay, so what I really need to do is... I don't think I need this. This might be useful. So if we just say... Okay, I always get this wrong way around. What does this do? And is it going to complain? Is it going to break because I haven't got the proper line endings? Im. Now what do we get? Probably val 0? Okay, so that's actually interpreting the spaces quite nicely. Should check at line endings. If there's a... So im. Val 0. 31. Now what do we get? Copy, so it works fine. Right. And I cannot, however, because you cannot switch on strings. You can do it though, with enums. You can do it with enums. Oh, I do actually need to pseudo hash the strings. Which basically ends up being a lookup table anyway. So I need to buy a new mouse. Damn it. Yeah, I need to work out what's happening for... I'm going to play fives this evening, but we may or may not be going early, which means I need to eat early, which means I might need to eat. There's pages in German. This screen is available in Germany. Go programmable buttons. Thursday the 8th. How much is it? It's in euros. I'm buying a mouse live on stream. So if I were to proceed to checkout, how does this work? Exchange rate guarantee fee. I could pay 51 euros. Okay, hang on a second. What's the euro doing? How's it? Point. €1 is currently... So I'm paying more, but... Europe... Botswana, no. Germany. If I be purchasing a card, I have a debit card. What's that? Do I have? I don't really want to reveal any of my bank details. Oh, it's a slightly better exchange rate. Yeah, okay, we're getting this mouse. Right, okay, I need to go and see what's happening. So, I might be back. Well, I will be back shortly, but I may or may not continue streaming. Trying to arrange this now. I'm getting no responses, which is not very helpful. You know, I can't go and play fives without eating dinner first, so... And also my dad's cooking, who's notorious for us having dinner rather late. I can do a bit of this. And I guess we just do like an if. Why can I not? Strings aren't convertible to bool, I guess. I can't do a switch, so this is the next best thing. My door's open. So what am I actually going to do here with... So we write that, which is the immediate instruction. Then we... This should have length 7. We'll go type equals Oh, wait, we have to put an extra 0 in. Oh, I can't call it register. I mean, that's kind of makes some sense, I guess. Deletion dot. Can I? Oh, back? Wait, this is actually. Car. That. Apologies, that was probably very loud. Okay, that's fine. Then I need to convert. To -1 it shouldn't. Generally, typically, you would expect indicates an error. So. Where is there no audio? Desktop audio. Oh, there is. It's kind of quiet. If and then register is in binary, so I actually need to. It's a character. It should be a number from 0 to 7. I need an ASCII chart. Can I have one that doesn't just have like cookies all over the place? Oh, it's not the Wikipedia table. Those will do. So where's 0 is 48. Why, I don't care what it is in octal. So we subtract 48. Which should give us a number, and then car. Is there any? You subtract 48. I mean, that's the classic answer. Oh yeah, I actually don't have to subtract. I could do this. That's a neat way of doing it. there a nice way of doing it? That is bit said. So if we're gonna use, oh wait, do I have to? I have to include. So let's try this. Oh wait, did I set the length as a type, as a parameter, as a generic parameter? Oh, what is it? No, how do I do it? I do this. Oh, let's see what it is. Bits. Oh, hey, look, 000, and they're unsigned longs. You know what? That actually is what I wanted. Um, these. this correct? It encountered an error. It did, however, write to the file what I was expecting it to write to the file. It behaved actually exactly as I would have expected. So now, put the rest of it Wait, what if we put it in as an int? Then it should be 8 bits, so then we do... This might work. Of course, because they're in reverse order. Okay, why did it not write? That's what I wanted to do. That now needs to be a string. Ta-da! .001. Oh, I wrote a different instruction. That's why it's not the same. Right. Okay, so that works. Right. So if it's copy, did it write the next line? It did put the new. It did put the. Put the line. We do all of that again. Wait. As a more efficient way of doing this, we can go like this. I think. Yep. Right. So we've done that. Now we need to grab. Yeah, this is returning because it's an int, so it's returning and unsigned, signed nonsense. So instead, I'm not really building a computer right now. I'm writing an assembler because I'm writing an assembler in C++ to assemble my assembly code for Turing Complete, because that's exactly how the devs have envisaged the game being played, I'm sure. So what do we need to do here is we need to go yeah, if you try and write to input as a pointer, you get like output as a pointer. It's nonsense and you get undefined behavior, and I don't care. It'll probably write to 0 in the RAM or something. Reading from the input, interpreting it as a pointer might work. I didn't implement. How did I implement? It's slightly weird. It doesn't quite work properly. Yeah, if you try and save as a pointer, it would enable RAM saving. But you would end up with garbage on the load line. I think you just wouldn't update the address, so it would just write to whatever address the RAM was already sitting at if you tried to write to the... if you tried to write to the output using it as an index into RAM, if you tried to load from the input using it as an index into RAM, it might work. I don't really care if it works. And then we can reuse type. I can't do that. Clobbering. Can I do this? How do I can't remember how you do this. Do I just do that? Yes. Reconstruct it to a new one. This is gonna have to be like that. Maths. What's the 2? Oh yeah. So we have to right 0B 0 1 0 1 0. Then we got an operation. Alright, so we do that. Then we have... Put it in there. Then we need to subtract... And then we just... We just do this like twice. Except here, we have to write an additional new line character. And then for bit manipulation, and then I'm going to try and rewrite my program and see if it disassembles it. Right, if the instruction is bitwise, we do the exact same thing. The difference is this will be 011 and this will be the operation is different. Or we do 0 if it is a 1 if it's NAND. The difficulty is the conditions which so actually I'm just going to put this here even though it's This will no longer assemble properly. I don't think we actually need these. It does not yet support comments. I should actually, if... that will ignore commented outlines. Which means I should actually just be able to... and do that, and then it should still assemble. In theory, if my code works. Right, so if it's condition... and then we've got two useless bits. We'll just write zeros. Then we... oh wait, no, not or. If it's false, then we write... It's not or. What am I talking about? This should actually be... zero. If function equals no equals Right. Then it's the same as the maths. We just need to read two values. Right. So let's see. Okay, so we've got this unassembled, which, and then I'm going to assemble it. Local autos. Oh, the autos would probably be pretty good actually. Diagnostics, so we don't need that for now. Right. So put this up over here where I can see it. So the first line is immediate val 031. Skip that. Instruction im. Then I'm going to use the keyboards in file. Yeah. Like destination val 0. Reg has 0 in it, 48. Type is val. So we stick that in there. It's to 0, bit set, bits 000, as we would expect, because it was 0. We write, value is 31. That is then 31, which is a bunch of ones. We write. We haven't reached the end of the file. It's not a comment. Instruction is copy, so we jump down to the copy. We write that. It's 49. Do we write a 1? Should be val 0. Next one is a maths. Should add adding register 2. Right. It's assembled something. Right. So I'll look at my unassembled. So I'm going to run this. What this should do is it should first of all write the value 31 to register 0. It wrote the value 41 to register 0. Damn it. Okay, that's a bug. What on earth did that happen? Radius 31. That is 31. Zero B 000. $41. That's 31. Okay, I don't know what happened there. Try this again. Should write the value 31 to register 0. Then we should copy the value in RAM. Where is this at 1? Oh, because we're doing gibberish over here. That's why the RAM address pointer has been moved. And we're also loading from RAM. But an immediate does not read values. So we're reading from RAM, but we... Thanks. We're reading garbage data from RAM, but we're not looking at it. So that's fine. So what we should copy... Because register 1 has got 0 in it, so we should be reading this value in RAM. This RAM is upside down. Maybe I could have put it over there. The RAM is upside down. And copying it to here. So we should put a 0 in there. Damn it. Why are you not working? These numbers aren't correct. How does this happen? Right, that is 0. That's 31. This is, in fact... Oh, that is 41. I'm stupid. This should be 001 01001. Oh, because I've forgotten how my assembly works. This is, in fact, copying the value 31 to address 0 in the RAM. Because the destination comes first for reasons of consistent self-consistency. Then, next, we should be adding the value here, which is 31, to the value in RAM at the address in here, which is also 31, to each other, which is 62, and putting it in this register here. So it should put 62 in there, which it does. Then it should subtract this value from the value in RAM at that address. No, it should subtract the value in RAM at this address from this value, which was 31 minus 31, and put the result there. So it should now write 0 to this register. Then we should be doing a bitwise OR on this value and the value that this is pointing at. So we should bitwise OR 31 with 31, which would just be 31, and put it in here. So now this should get set to 31. It doesn't. Okay, what's gone wrong here? We're reading 31 and 31. I hooked it up wrong. It was reading the condition instead of the bitwise operation. Okay, so we put 31 in there. We put 31 in there. We put 62 in there. Then we put 0 in there. Then we should be bitwise ORing this 31 with that 31 and putting the result, which would also be 31, in here. Indeed, that is what happened. So we're in bitwise mode. So this is bitwise. 97 is a bitwise OR. Or more importantly, this 1 is irrelevant. It means something else. These 2 bits are low. It's actually reading these 2 bits. This bitwise is only reading these 2 bits, which are both zeros, so it's doing an OR. So it's bitwise ORing them, and that obviously just gives you, if you bitwise... Yeah, there we go. This turns on, so you bitwise OR with itself, we get 31. We write it, and we wrote it to there. Then we should check the condition false, and, well, we should check this 31 against false, and if the condition is true, we jump the program to whatever's in this, which we won't do anything because the condition is false. And then we hit the end of our written program and we stop. But it does work. So if I change this to be greater than or equal to 0, then it crashed. What went wrong? Doing maths. We can add. More maths. Doing bitwise. Write that. Operation is an OR. So we write that. Register 1. Right, so now we're going to execute a evaluate condition. Is val 0 pointer 1. Ah. It worked. This just should continue. Why does it still exit with code? Is it assembling correctly? It is assembling code, I think. Oh, I don't want this CPU. I want this one. No, the other C++. There are like two C++ references. One of them is like way better. Did I not peek? Okay, so that's what I would have expected. It's because of /n. So what I actually need here is to say if that. Yeah, okay, that gives me a C. But now exiting with code 0. So now I've slightly changed my code. So we put 31 in there, then we should copy that 31 there. Then we add this 31 to that 31 and put it there. Then we subtract this 31 from that 31 and put it there. Then we bitwise OR this 31 with that 31. Put it here. Then we should check if this value is greater or equal to 0, and if so, we should jump to the program address. We should check the RAM. We should use this as an index into we should jump execution to the value stored at this RAM address. So which is 0 because we've only written to decimal 0. So it should jump execution. It should reset this to 0. It doesn't. We got 128 coming in. Why is it 128? It's not what it's written. Okay, yes, it wrote 0 because the 31 is greater than or equal to 0 and we're in this, so therefore all this turns on and we read a value from this address, which is complete nonsense because I haven't written to it. So we read out as we enable the overwrite pin on here, set a 0. So now we go back to the beginning. Although it actually do something slightly different now. Because now we will... Why has that got 31 in it? Because we just wrote 31 there, I suppose. Because we wrote 31 here, and then we will... Oh, because we copied this value, because this is now pointing at... This is now we copied 31 into here, instead of into here. And then what? We're going to jump to program execution to 31. Which is an offset. We should never be here because now we're reading nonsense. And if I keep going, it'll constantly do nothing. Then it'll read garbage. Okay, my assembler works. That's enough for today. Goodbye.